like many of you out there, I have been planning for a long time to come to Jackson Hole and to be here on August 21st, 2017 at 11:35 in the morning. That's because we have a precise, mathematical, predictive model for the way in which the solar system works. And we could predict to the second when that sun would appear. And sure enough, exactly as if on cue, the moon came right in front of the sun. I hope you all had a beautiful experience with it. I know that I did. Our ancestors were not so fortunate. They didn't know when it was going to happen, and if you had the same experience that I did, you know that it can be very scary, especially those last few seconds when it just goes dark. Very scary. So how to understand such a thing? What did it mean? Well, they had stories, and most of them involved murder, or to be more specific, devouring. And since the sun always came back, it also involved regurgitation at some level. But we don't have to be afraid. And while we can still enjoy stories like that, they don't need to be our model of the solar system. We now have a model so precise, you can go on NASA's website and see when and where the eclipses will be for the next 3,000 years. We can see all of the eclipses that James T. Kirk will see in the 23rd century and 700 years beyond that. So that is into the future, and yet we can tell you where and when. That's how good our model is. So I was very fortunate enough to spend many summers of my youth in Kelly, Wyoming. I was a rough rider at Teton Valley Ranch. Every morning, looking out at that mountain was a pretty inspiring thing. And a lot of my life and mind and spirit were formed here in this valley. This was long ago enough that I came out to Jackson my first time on a Union Pacific train. And the Challenger Streamliner, the ultimate in modern transportation, left Union Station in Chicago at about 6 o'clock at night. I got on that train, and within minutes, I met my friend Annie. And she was my best camp friend for all the years I was here, and she's still one of my dearest friends today. I'm sure there were adults on that train, but I didn't see them. And Annie and I spent all evening, all night, all day running up and down the train. We played cards in the bar car and ordered up another round of Three Musketeers. We spent endless hours in the observation car. And when we finally landed in Rock Springs, Wyoming, we took what seemed the longest bus ride imaginable up from Rock Springs to Kelly. When I got on that train, I thought I was headed to the Wild, Wild West. I believed it. I believed all of it. My mother believed and said that she wanted to keep us as innocent for as long as possible, as innocent as possible for as long as possible. And she did. It was to foster our imagination, and I really thought I was headed to, it could have been 1885 for all I knew. I had my lariat, and I had my slicker, and I was ready to ride the range. So when I got to Rock Springs and headed up to Jackson, the sun set. I was sitting on the left side of the bus with Annie next to me, and we saw our first star, and she taught me how to wish on a star. I'd never heard that before. We picked out two stars that she picked out Vega and I picked out Arcturus, that any time we looked at those stars, we could think of the other and know the other was seeing that star as well. So the stars of Jackson Hole and the stars of that experience were a huge part of my early friendship forming as well. When I got to Kelly and stepped off the bus and saw the exquisite night sky of Jackson Hole, I couldn't believe my eyes. It was nothing like Chicago, I can tell you that. And summer after summer, I got to experience these beautiful stars in this beautiful valley. I was kind of famous for falling asleep, not under the tarp, but out under the stars. And I had my glasses on, and I kept them on until I fell asleep. And in the morning, the glasses would all be askew and probably rolled over on top of them. But at least I got to see the very last seconds of the stars before I drifted off to sleep. So summer after summer, I grew here, and it wasn't just my lariat skills. It was also the way I understood people, the way I understood the world, the way I understood the universe. My spiritual life was here. My mother didn't really like church. She didn't believe in organized religion. So my one and only religion was forged here under the cathedral of these stars. So many years ago, a friend gave me a tile that said, "For I have loved the stars so dearly, I cannot be afraid of the night." And that is how I feel. I loved these stars. And my form of love was to learn about them. So I chose the path of science and went on to graduate school and studied astronomy. I had an extraordinary experience when I was just in the middle of my graduate school that really solidified my love for science. In a galaxy far, far away, in February of 1987, a supernova went off. A supernova is a star that explodes at the end of its life, and after it explodes, it becomes so bright it outshines the entire galaxy. So there's a very characteristic brightness that star shows, a supernova. It gets brighter, and then it falls off and gets dimmer in a very characteristic curve like this. So I was studying stellar interiors, and I had learned that the cooling of the supernova and the dimming of its brightness was exactly related to the decay times of some of the nuclear products that were forged in the supernova. When a supernova goes off, it's so hot and so dense inside that all sorts of nuclear reactions go on and all sorts of different isotopes are formed. In particular, there is an isotope of nickel, nickel 56, that is supposed to, I had learned, dominate and dictate the decay of the supernova. And sure enough, as the weeks, months, and as you can see, years go by, it was spot on. It was exactly right. How was this possible that I could know ahead of time that some crazy isotope of nickel was going to tell me how quickly this star would dim in a galaxy far, far away? But science could do that. We know enough to know what those nuclear reactions are and how it would affect how bright the star looked. So this was my Helen Keller moment, when Helen Keller touches the water and realizes that water is the same as those patterns she'd been learning. Science was a path to really understanding and being able to predict what the universe was like. So I want to tell you two quick stories of more recent examples of mind-blowing times that science has predicted and observed crazy things. And I hope they will have some of the same feeling for you. The first is the collision of two black holes. And you know that they're very dense and very energetic. And black holes, like you and I and the Earth and everything else in space, sit in space-time. And space-time is just this fabric of space and time in which everything exists. And space-time is kind of like Jell-O, that if something energetic happens, ripples come off of it. Einstein understood that. He understood that space-time was curved, that gravity causes this curvature, and that big ripples or big explosions in space-time would cause ripples. But he thought nowhere could we possibly measure this, because the amount of wiggle of space-time is so minute, you couldn't possibly measure it. Here is an example of showing how the ripples of space-time might come past the Earth. I love scale of effect is vastly exaggerated. That's a relief, because that would be very bad for us. But in fact, the scale of the ripples is 1/1000th of a proton in its size. That's how small they are. How could we ever measure something 1/1000th of a proton in extent? Well, sure enough, we've measured it with the Laser Interferometer Gravitational Wave Observatory. Just in this last few years, we've seen now 4 of them. There are probably more they haven't announced. But 2 different observatories, one in Washington, one in Louisiana, got the same signal, that wiggling signal that is the oscillation of space-time from the collision of two black holes, billions of light years away. The other example I want to give you is about this beautiful, wonderful spacecraft called Cassini that is at Saturn right now. It has been at Saturn since 2004, and it's been sending back these amazing pictures. You've probably seen some of the rings of the moons of the planet itself. Now, Cassini was launched in 1997, and it took this crazy path. It got gravity slingshots from a number of the planets. And as we talked about a minute ago, gravity is really just an effect of the curvature of space-time. So if you think about how the spacecraft maneuvers, it has little maneuvering jets, and then it falls and makes use of the curvature of space-time. So I'm imagining that there might be some skiers in this room. You know what that's like. You see the curve. You want to cut it this way. You want to cut it that way. That's just what Cassini did for nearly 7 years. As you can see, it started in the launch here. It went around, encountered Venus once, got slingshot out to about the distance of Mars, had a little maneuver, got another encounter with Venus, had an encounter with Earth, and on to Jupiter, which gave it another slingshot to Saturn. So 7 years of whoa, 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 and finally to Jupiter, and finally into Saturn. And after nearly 7 years of this, 210 million seconds, it came and fell right into Saturn's orbit within 4 seconds of the predicted time from 10 years ago from mission planners. 4 seconds. So that is, wow. Thank you, Cassini, and Cassini scientists and engineers. Well, there's a little bit of a sad story here of this amazing mission, because it has been exploring Saturn almost 300 orbits using that same gravity, rolling around, bouncing off of the moon Titan, changing its trajectory all around to get all these different views of Saturn. But this fall, something kind of traumatic is going to happen for Cassini. You know how you marked your calendars for the 21st of August? Well, I would like you to mark your calendars for the 15th of September, because that is the end of the Cassini mission. The Cassini planners don't want Cassini to fall into and accidentally crash into a moon that might have life on it. We don't want to contaminate possible life on moons of Saturn with bugs that might be riding along with the Cassini spacecraft. So sure enough, one of those last maneuvers on the 11th of September will cause it to bend just enough and fall into Saturn's gravity, and finally it will burn up in the atmosphere. Now, we won't be able to see anything, but we will be able to see the very sad faces on the controllers at Jet Propulsion Laboratory as they say goodbye to their mission that they've been working on for over 20 years. I can guarantee you, or let me put it this way, I will bet you a Three Musketeers that will come off exactly as planned, exactly when planned, because that's how well we know the solar system. That's how well our science and our mathematics works. So why would we ever turn our back on science? It has so many opportunities and offers so much to us. It gives us a way to travel around the solar system. It gives us wonder. It gives us safety. It takes us out of darkness. Now, some may think that there's a conflict between science and appreciating the beauty and wonder, but I do not. I still delight in seeing the first star I see tonight, every night. I still think of Annie whenever I look at Vega. I still can lose my breath at the beauty of a solar eclipse. So I see no conflict there. Knowing that that was the moon coming out in front of the sun made it almost more amazing, more beautiful. I've also heard it said that science may be unapproachable to some because there's a conflict between science and faith. And I don't think that's true either. I think of it as sports. I really love baseball, and I really love football. But I would never take a baseball bat onto a football gridiron, and you would never tackle somebody on a baseball diamond unless you were trying to steal second base, right? So they're two different games. And when I need to ask something about the physical universe, something that science can answer, I play by the rules of science. And when I want to ask something about the meaning of my life or my soul's path, then I turn to my tools of faith. They don't have to be in conflict with one another, and that has worked for me. Thank you.